SwayamPrabha. Digital India. Educated India.
Welcome to the course on building energy systems and auditing. We are in the last module, module 8. In the module 8, we will again going to go through 5 lectures. The topic of the module 8 is green energy and sustainability. So, in the 36th lecture and the 37th lecture, we will discuss the solar energy. So, in 36 we will discuss the part 1 of it. In this module and in this particular lecture, we will discuss about the renewable energy application in the building, and also we will see how solar PV components and energy calculation is done through some steps. So, if you see the renewable energy is integrated in the building systems and all. So, one of the component of present building system is the renewable energy systems. If you remember, in the very second module we have discussed about the lot of systems. It starts with the HVAC, then lighting, then other type of systems like the lift and escalators and all, and also the low energy building systems. But there I think I have mentioned that another systems is the green energy systems or the RE systems, which we will discuss in the later. So, in the 8th module we will going to discuss that. So, as you know that almost about 40% of the worldwide energy is consumed by the building annually, and as per the report of the International Energy Information Agency, that each year is almost the energy expenditure and expectation from the people which will be going to consume some kind of the building energy is increased by 1.4% per annum, and it will go through till 2035 or so. So, each year there is a huge potential of the demand. So, there are two approaches that we can take to make two kind of the compromise, or two kind of the two ways, I may say that two ways of the energy balance with each other. The first one I have written down the 2 points. First one is the reduce the need of the energy, that what we have discussed till far, that we can use some kind of the passive systems, we can think of some kind of envelope, re-envelope design, even we can think of sometimes the retrofitting of the buildings and all. So, based on that implementation, we will try to reduce the energy pressure or energy demand. And the second, offset the remaining building energy by need from the renewable energy source. So, offset the another part, which is the additional part of the subset of the total amount of energy part, we can actually think of the harvesting from the building itself or in and around building itself and through the renewable energy sources. So, in the renewable energy sources, what are the sources? That there are maybe plenty of sources, but what are the sources we can actually use for the building integration in the building? First of all, that reminds us is the solar energy. Then it is a wind also we can think of. There are many buildings which actually the present days employed the wind turbines and all those, and generate the energy from the wind. Then the geothermal energy, we have discussed that one in low energy systems, that from the heat pump systems and all we can actually use some kind of energy. Then we can go for the biomass. We will discuss this wind and biomass at the 4th lecture of this particular module. And also we can think of some kind of a fuel cell, which not going to be discussed this module, but we will define that what is fuel cell and all in the subsequent lectures. In the solar, if you see, there are so many types of solar energy potential that the building can be integrated. One is the straightforward the photovoltaic cell, solar photovoltaic, solar PVs. Then we can actually go for the building integrated PV systems, BIPV. So, in the surface of the building we can integrate the PV systems. We can think of sometimes in some of the buildings where there are hot water is required for the solar thermal systems, and also you can use some kind of a hybrid solar PV systems also, that is the solar photovoltaic and the thermal both can be integrated with each other. In case of the wind also, we can have two different level of the wind generation or the energy generation from the wind. One is the community level wind turbine and another one may be the building integrated wind turbines or so. Now, in the further, when we can think that what are the potential the potentially when I can think that the renewable energy can be integrated in the building, there are some factors and we have to check each and every factors, and then only we have to decide that yes, we can actually go integrate that the RE or the renewable energy system, and which type of system we can integrate, that also depend upon those factors. The first one, if I just go through one upon another and discuss a little bit, then let us say that available renewable energy resources at or near the building site, that is one of the most important thing. What are the sources is available? If your building is a very low height building and it is surrounded by high rise building also, I think we cannot go for the solar, because there will be always the high rise building in and around will cast a shadow on the rooftop or on the building wall. You cannot go for BIPV or you cannot go for the rooftop solar PV. So, similarly, we can have to see that what are the sources that is available in the near the building, and about that particular nature of the building, what are the sources we can think. Available area for siting those technologies. Next is the cost of energy purchased from the electrical and the thermal energy provider of the building. So, that is also one of the issue. If the cost is low, we probably do not go for those kind of the RE systems, but if the purchase cost of the electricity is very high, then people may think of going for the renewable source, because that will be cheaper. Available incentive for the offsetting this installation process for the renewable energy systems. So, sometimes people may think of getting very some subsidies and some kind of some relaxation in their taxation or something, if you go for the renewable energy sources from government. So, that is also one of the very important issue or important factor that people might go for or might opt for those renewable energy systems or so. Local rules and regulations affecting the renewable energy systems, that is also very important, because sometimes the building bylaws, local building bylaws, the height of the building, and sometimes that some kind of the tenant and those kind of the other issues are there, and then maybe there are some kind of the issues like the amount of the floor area, and based on that the services required, or those are have some kind of restrictions, and from that point of view sometimes it may not be possible to opt the renewable energy sources, but those local rules are gradually they are changing those rule in favor of using the RE systems or so. Desire to preserve or not alter existing architectural features. Building architecture and the facade architecture has an important role to play in the building itself, and probably it is going to be one of the important the factor that actually the client can hold, and then probably they may not want to change those architectural features, and that may sometimes make some kind of hindrance to allow themselves for the regenerations or so. Characteristics of energy profile to be offset by the renewable energy installation. that it means that the what will be the characteristic, that means what will be the total amount of generation annually, and there will be some kind of fluctuations also, because these all renewable energies depend upon the natural resources or the natural climate and all the other data. So, if that is not going to be favorable for the profile of the energy generation through RE, then there may be some issues. So, if you see now we will go to the solar the panel systems also, those which is very common to us nowadays. And so, what are the panel and what are the kind of the assembly we can see? The first of all, a solar cell is there, which is a very small kind of a PV cell, electronics chips like. It is a 156 by 156 millimeter, very small in amount or the dimension. Those shells are actually going to harvest energy, and those are actually placed in an array, and that create a kind of a size of the module size of the solar panel size. It may be 2 feet by 4 feet or 2 feet by 8 feet, something like that, and that is actually created by these multiple those arrays, and they have some kind of the rating like 100 volt or 200 volt or so. Now, those arrays are one single array will be now put in a particular rooftop or maybe in some area where there are series of or the array of solar panels, and that all will going to harvest as per its rating and all, provided it does not hamper with the shades and all other issues. And these solar arrays are typically a design factor, and how much the empty area or the siting area is I have, how much is the area I have in the south facing or the west facing, those are the typical requirement. And finally, those array systems will have some kind of a supporting systems, we have to have some kind of a mounting systems and all. Based on that PV system will be fixed in a particular area. Next is the how this particular this systems is actually work. If you see in this is a very schematic kind of a diagram. It has very this solar arrays or the solar PV modules are having some kind of a the differential layers. It has mostly of the 2-3 layers. Out of that, in between this particular layer, there are a N type semiconductor and there is a P type semiconductor. Actually, it is electronics device. It is the motion of the electrons are basically seated on the principle of the semiconductor devices N and P type, and in between the N and P type there is a junction which we called as a PN junction, and there are above the N type there is a the solar some glasses are there for the kind of protections. So, solar the rays that the radiation when it comes through this particular penetrate through this glass, it excited the N type the semiconductor, and there are some cathodes and anodes will be arranged in the topmost portion and the bottommost portion, and in that particular N and P type in between their junctions there is a ion exchange, and N type will be having the higher the accumulation of the electrons or the negative atoms, whereas the P type will have the higher accumulation of the positive atoms or the positive charges. So, there will be a flow between two electrodes, and through that flow of electron we can actually harvest some kind of electricity. This is a very basic way of understanding the solar PV systems also. Now, this particular solar PV system has various components. We have a tracking systems which can track the solar path or the sun path. We have mounting systems. We have, yes, sometimes tracking systems we may not provide because it is again a costly affair, or maybe it is going to have some kind of other electronics devices. So, we can have only mounting systems and fixed the inclination. We can there must be some kind of a cables, there is a DC isolator, there must be some batteries of course, because we need battery to for the use of this particular electricity in the night time or the other time. It need a inverter, AC isolator, charge controller and the electric meter. So, if I see now how this particular circuit is going to be arranged and what is the work of the each and every component, then first of all we have to have some kind of the solar PV that we have discussed, and as many as solar PV we can actually put as per my demand, and maybe and also as per the area or the space available. So, from the solar PV it has to go to some kind of electronic device called charge controller, which will going to control the amount of charge that is generated in the solar PV systems because of the solar radiation. So, it should not overcharge the battery, it should not going to give you some kind of a damage to the battery. So, it will control that particular charge, and that will be connected to the battery systems. So, battery will actually now take, I mean it will be charged, I mean it will now taken it will be fully charged after some kind of hours of operations or so by this charge controller and from the PV, and from the battery it will go to the inverter. Now, this is one of the important thing why I need an inverter, because almost in our country almost all the loads are electrical loads are the alternative current load, that is the AC kind of a load, but you cannot store the current in a AC current in battery. You have to actually and you have to be actually battery will be actually actually store the direct current, DC current, which is a does not have any kind of amplitude or so. So, whatever current comes from the battery is a DC. So, you have to again invert it to a AC. So, that is why you need inverter, and then you can use it for the alternative current applications or so, and that is why you required a kind of inverter. So, after the inverter it goes to the electric meter, and then from the electric meter it goes to the different type of load, that my light or maybe ceiling fan or anything. But if any such the electrical equipment can run through DC, then this inverter may not required, and we can directly connect the battery to this DC load. Nowadays we are thinking of there are some product which is coming with a DC product which can run through the DC to bypass this inverter effect or so. So, if there are some portion of the building or some of the equipment of the building is AC and DC, then we can directly take that AC things directly to the inverter, and otherwise it is going directly. So, now let us see the how to estimate the solar power and all those. So, there are two methods. This particular lecture we will discuss the first method, the next lecture number 37 we will discuss the second method. So, in the first step we will determine the photovoltaic array area and its efficiency. So, how much area I can provide, that I have to see from the space and from the available area or available dimension of the rooftop or whatever, and also I have to see the how much is the efficiency of those kind of the PV that I am going to install. Unfortunately, till today the module efficiency is not very high, it is 10 to 20% is the efficiency of the module. People are actually doing lot of research in this area to improve the efficiency from 20 above or so, and this efficiency is called as a conversion efficiency. Please remember that this efficiency of what I am talking about is the efficiency of the solar power panel, PV panel. It is not the efficiency of the whole system. Now, when I say about the whole system, it does not have only the PV panels, it have the charge controller, it has a lot of other things like battery, it has a the inverter. So, each and every component has its own efficiency, and it is a complex efficiency can be calculated or determined by this virtue of the some calculations or some kind of the approximate assumption. So, this 10 to 20% is the efficiency of the power system, the solar panel system. So, now the second step will be to determine the tilt angle of the solar array. So, what should be my angle of tilt, that such a way that in the maximum time I will get the perpendicular radiation, and perpendicular radiation from the sun will be definitely better than some inclined radiation, because that will reduce down the amount of the harvesting or the energy generations also. The tilt angle is depend upon the solar lot of things, that your latitude and the location and latitude. It also depend upon the date when I am going to calculate the tilt angle and also time. That means, this tilt angle is actually depend upon the solar altitude angle. So, suppose this is your solar altitude angle, this is the solar altitude angle, and then the tilt angle can be calculated by 90 degree minus the solar altitude angle. So, this is your tilt angle, this is the TA, if I say TA, and this is the solar altitude angle. So, definitely the relation between them is 90 minus solar altitude angle. So, and you see it is every time it is changing, even in a particular day, in different time the solar altitude angle is changing. So, your tilt angle should change, but that is not possible. So, what we can do is that otherwise we can go for some kind of a tracking system, the electronic tracking system, which I can set some of the standard or some kind of the parameters. So, it automatically it will track, and then your tilt angle will change, or otherwise we can actually fix two typical tilt angle, one for the summer and one for the winter season, and that may help me a bit, because I do not require another type of system in another investment in the solar array, such a way that it can be that your tracking system may not require. So, there is a thumb rule. That thumb rule is that the optimum tilt angle, see it is optimum tilt angle, and this is a thumb rule. Rule of thumb is that the adding 15 degree to your latitude during winter. Okay, so, suppose your latitude is 30 degree north, then you add 15 degree, that means 45 degree. So, I told 45 degree in time of winter, and in case of the summer you subtract 15 degrees. So, it will be 15 degree, 30 minus 15 is your 15 degree. So, it is plus and minus 15 degree in time of winter and summer respectively. So, in winter I will actually tilt it at about 45 degree, and in the summer I will tilt it about 15 degrees. So, as in case of the summer, the solar altitude angle is very high with compared to the winter. So, you require a lower amount of tilt angle, because the relation between the tilt angle and the solar altitude angle is 90 minus solar altitude angle. Okay. So, as and when the solar angle is high, you require a low amount of tilt angle, and in case of the winter, you know that the solar altitude angle is not so high. I mean, I am talking about the approximate, the solar altitude angle is not so high, it is a low sun movement. You require high amount of tilt angle to make perfectly perpendicular to it. So, this can be used and as a thumb rule, and you need to take the third step is that determine the monthly average solar radiation data you need to generate, or you need to get it from some website or some kind of a data book. So, this is one of the data book gives us some the yearly or monthly the radiation and all the some of the cities of in India, and this is given in kilowatt hour per square meter per day. So, per square meter per day, how much kilowatt hour the solar radiation is actually implied, that is given over here. And it see, if you see Ahmedabad, suppose the first row, it is 6.41 in January, that much kilowatt hour per meter square. February it is again little high, March again high, and then gradually maybe in July, August it is very low 4.26 and 4.56. Because those days are cloudy days, because it is monsoon time, those days are cloudy days. So, in India in monsoon you will get the lowest amount of solar radiation. So, that data is required in the third step, and then we can find out the calculate the energy output from the monthly databases or so. So, we will do a small problem over here. Suppose this is a rooftop the plan of a building, which I am going to have some kind of a PV installation. All dimension, there are two part of the rooftop, it is a L kind of a shape of a building. There is a corner of that two wings, there is a service area, and I have 13 meter by 5 meter of the one side full rooftop area is for available for my solar installation, and another side is 12 meter by 8 meter is the area which is available for the installation. So, I will going to install the solar panel of conversion efficiency of 15%. That data can be, how that data is actually calculated and all this we will discuss in the next slide, next lecture. Let us suppose it can give 15% of conversion, and the solar panel size are 2 meter height and 0.6 meter 2 feet width. So, 8 feet by 2 feet. It is recommended that south facing solar the panels will be mostly effective to produce electricity, and it is in Mumbai. So, the latitude is 19 degree north. So, first of all what I have to do, I have to find out the tilt angle both in the summer and winter and take the highest one, and then I have to see the how I can actually fix it and how much panels I can fix it in my rooftop. So, I know that with the thumb rule, winter I require 34 degree as a tilt angle and the summer I require 4 degree, with 19 plus 15 and 19 minus 15. So, now by the simple arithmetic the trigonometric calculation, I found that this is the blue color, the slanting line is the solar panel height, that is your 2 meter height, which I have mentioned over here. Let us suppose it is h. So, the ground projection is your base. So, that particular portion is your base portion, and that base portion is your h cos theta, where this angle or the tilt angle is your theta. So, either it will be 34 degree or 4 degree depending upon your winter or summer. Now, the next one will be provided somewhere here. So, this will be this particular dimension will be your row spacing, and the row spacing will be about h sin theta into tan theta. Okay. If I just reduce it, then what, suppose if I start it from here, so this portion will be always under shade, right. This portion will be always under shade, because the sun will come, rays will always give me a shade of the earlier one, the earlier in the row, the solar panel. So, it is mostly effective if I just see the tilt angle and then I decide that where will be the foot of this particular next row, and then I decide about the row spacing. So, row spacing I have calculated, because if this is your theta, this is also going to be your theta, and this is your h sin theta, and then this will be your h sin theta tan theta. Okay, this portion. So, this will be. So, I have calculated the base as the 1.66 meter for winter, and your the row spacing at 0.75 meter. So, adding this to it is 2.41 meter. But in case of the winter, in case of the summer, it is 4 degree. So, this is 34 degree I have used for the winter, and this 4 degree I am using for the summer, right, for summer, and I got the row spacing as 2 meter is required for the summer. Row spacing, not row spacing, the row spacing and the base both. So, this two whole spacing, the spacing of the row spacing plus the base is your 2 meter and 2.41 meter. So, I will have to take the 2.41 meter, because the highest one I have to keep for my the design calculations also. So, 2.41 meter will be my spacing. So, now I have this dimension, and I am going to put the array such a way that it is going to face the lower side, the southern face, and in that what I did is that I have kept a particular 2 feet, that 0.6 meter in and around this hatched portion, the red color hatched portion as the circulation area. So, as the circulation area is 0.6 meter, now the left area is going to be calculated for the module size. So, in this particular 13 meter by 15 meter is now reduced to 5 minus 0.6 and the 13 minus 0.6. So, 13 minus 0.6 divided by 2.41, 5 is almost equal to 5. Why 2.41? Because it is the rows of the base and the row spacing altogether I am using 2.41 meter that we have calculated. So, 5 will be in a row, and number of PV panel in each row will be 5 minus 0.6. So, 5 meter is total, 0.6 is deducted because of the circulation, and 0.6 is the width of the one module. So, about 7 in each panel in each array will be accommodated. So, 7 5s are 35 modules or panels will be accommodated. So, here also I did the same way, 8 minus 0.6 divided by 2.4 is 3 in a row, and the panel in a row is 35. So, almost about 105 modules panel will be in a row. So, I have calculated 2 dimensions of the I have 2 dimensions, I have deducted 0.6 from each dimension, and one I divided with 2.41 and another I have divided with 0.6 to calculate the number of rows and number of PV panels in a row and multiply that. So, that gives me number of rows. So, total I have now 140 panels can be accommodated in that particular rooftop facing south. Each module size is 2 meter into 0.6 meter. So, 1.2 meter square. So, total panel area is my almost like 168 meter square. I am in Mumbai. So, I will use this data. So, this data are used. Now, let us see how I have calculated this data. So, this monthly average solar radiation kilowatt per square meter per day I have tabulated from the table. So, it is, you see, it is January, it is 6.51, February 7.06. So, similarly 6.51, 7.06, that I have tabulated January to December. Now, daily average output in watt. So, daily average output in watt will be the total monthly average intensity multiply the total exposed area into the conversion efficiency. So, in case of the first row, how I am going to get this one is 6.51 is the January data per day. In the January per day, you see the per day January 6.51 kilowatt hour per square meter can be generated. So, next I am multiply with the meter square, this is the meter square and this is the efficiency. So, that means 164.05 kilowatt per day can be generated in the month of January. So, 164.05 kilowatt per day. So, if your total amount of load per day is something like 160, 162, it is good. So, it can be actually take care of that. Number of days in month, that month 31, January is in 31. So, monthly output megawatt per month will be 5.09. So, monthly output I have found out the daily average output, which is this 164 multiplied by 31 number of days, whatever comes I again divide that by 1000. So, that gives me the megawatt, this is that gives me in the megawatt. Okay, like that I have calculated for all the months. So, I see that the highest peak will be almost around, let me go to the next slide. So, that gives me the total data. So, it will be almost March will be the March, April is the almost peak, and the July, August will be the June, July, August will be the little low. So, we need to see that. Even November is also very good, December is also well, October. So, that way we can see that the monthly average and the daily average also, and then we can take some decision that yes, what should be my total load I can think of to go with the solar PVs also. So, that is all for this lecture. These types of renewable energy application in the building we have discussed in a brief, and we have started with this lecture the solar energy integration with the building within the building. So, thank you very much.